Welcome to my video on measuring the density of aluminum, mass, volume, and error analysis. So what is the density? Density is defined as the mass per unit volume. Here's our formula. Rho is equal to mass per volume. And the density is typically recorded in grams per cubic centimeter. The mass would be in grams and the volume would be in cubic centimeter. Next, I'm going to show you a video where I took the measurements of the dimensions of the aluminum bar and the mass. First, I want to take the measurements of the mass of this aluminum block, and it's approximately 25 millimeters by 50 millimeters by 100 millimeters. That's what I bought it as, so I think that's fairly close. First thing, let's measure the mass of it with the gram scale. You get 348.87 grams. So that's the mass of the block. Now I'm going to measure the dimensions. I've got my micrometer here, and I'm going to put it on the millimeter scale. Okay, let's zero it out here. Okay, that's a good place to start. Now, let's measure this dimension, which should be around 25. Yeah, I'm going to, all right, 25.32. Have to try to get it as perpendicular as possible. Now let's measure essentially the width of it. The first was maybe we'll call it the height. Okay, trying to get that as perpendicular as I can, 50.35 millimeters. Now the length, expanding this out here and trying to get this right on it so I get a good solid measurement. That's going to be 100.35 millimeters is the length of this aluminum block. So from this data, I can calculate the density. Now with the measurements in hand, let's calculate the density. The mass was recorded at 348.87 grams. The dimensions were 25.32 times 50.35 times the length of 100.35 millimeters. So those are the three dimensions of the block. And we need to use this conversion factor. We know that 1,000 cubic millimeters is equal to 1 cubic centimeter. So multiplying these numbers together here, dividing by 1,000, we get 127.88 cubic centimeters. That's the volume of our aluminum block. So now the density is just going to be the mass divided by the volume in the proper units of grams per cubic centimeter. So we take our 348.87 grams divided by 127.288 cubic centimeters. That gives us 2.73 grams per centimeter. So that's the density, the measured density of the block. Now let's see how we did compared to accepted values. So our measured density was 2.73 grams per cubic centimeter. The accepted value for aluminum at room temperature, and that's what this is, a room temperature measurement, is 2.70 grams per cubic centimeter. So this is really a very close agreement to the published values. So the measurement was reasonably accurate compared to what it should have been. But now with any type of measurement, there's going to be errors. So let's talk a little bit about the errors. First of all, we have the mass scale. That was good to 0.01 grams, so there's already an inherent error in that. The micrometer was good to 0.01 millimeter. Now thinking about all the different measurements, probably our largest source of error was in the single measurement of the shortest dimension of the block, 25.32 millimeters. The reason being in the 0.01 is a larger percentage of that, so it is our largest source of error. But overall, we saw it compared fairly well, the published values. So the calculated uncertainty now would be approximately 0.001 grams per cubic centimeter. It's going to be one standard deviation. So the final result is our density is equal to 2.73. Now we're taking into account the uncertainty we calculated with the error analysis, plus or minus 0.001 grams per cubic centimeter. So there's our results. Hope you learn a little bit about measuring the density of a solid, and also about thinking about the errors involved in your measurement and what kind of uncertainty that generates. Thank you for watching.